You know, when something is so cheap, you just have to buy it to find out how bad it really is. This is one of those times, so let's empty the box and see what we're getting for our money. So if we start at this end, we've got a BT30 to ER20 tool holder. That's this one here. And then because it's got a power drawbar on it, we also get a little M12 pull stud. And that obviously goes into this end here. So that's a BT30 taper with the drive dogs. And then inside there's the power drawbar that will pull up on the stud in the usual way. We'll get into the details in a moment. And then we've got our power takeoff here that goes through this belt, and then you can add your own style of motor onto there, because obviously this is not powered. And there's a 2-stage pulley on there. Same on the other side for the drive side. And then at the top here you've got an air cylinder that pushes down on the Belleville washers to enable you to do the tool change. Okay, I'll just put the price up on the screen and the eBay listing where I bought it from. Now, I paid full price for this. I've got no relationship with the manufacturer or the supplier. I've bought it out of my own money, and I thought it'd be worth a review because some of you might have seen it as well and might be wondering, you know, how good is it for the money? So yeah, let's get into some of the fine detail, and I'll give my views as to where I think they've cut the corners to deliver it for that price, but also, you know, what are you actually getting for your money, and is it good value? Now, one thing I will stress, we're just going to do this statically. I might do some runouts and things like that, but it's not going to go onto a machine, so you won't see it cutting. That will be many, many months away. If you're interested in seeing how it ultimately performs, you know, when it's actually cutting, feel free to subscribe, and when you see that pop up in your inbox, it might be 6 months away, you can dip into the channel there. Right, let's get into what you get for your money and what the detail specs look like. Okay, let's start with the tool holder. So obviously it's a BT30 into there, and then it goes to an ER20, so it looks like a nice size, and you'll get a nice range of end mills in there which feel appropriate for the machine. One thing the supplier does say is that the length of this varies, so if you buy some more of these from them, I didn't see their listing on the website actually, but they say that there's a variation from their supplier, so they highly recommend you go and buy some high quality tool holders if you want to have consistent length and achieve, you know, the best accuracy. In terms of accuracy, on their advert they quote runout of up to 0.05 millimeters, which I think is about 2 thou. Although typically you might see 0.02 millimeters, which is about 1 thou, isn't it? So in engineering terms, that's quite a lot, but at least they are honest, and they do say this is like a general tool. It's not high precision, you know, so at least they're upfront about that, and they're not claiming that it's a super high precision. So good for roughing, good for general machining, maybe just cleaning up edges, and yeah, there are a lot of applications where that kind of tolerance would be okay. But that is the first shortcut. There's a reasonable amount of run out. I guess that's spindle end. It's probably exaggerated by the time you get to here, but hopefully we'll put something together and we can have a look at that a little bit later in the video. Right, next up is the pull stud. So obviously this is the bit that screws into the top of there, and it's what actually holds it into the machine. We'll have a look inside in a minute at how they're doing that. But before I bought this, I asked the supplier of eBay, did they have a drawing for this pull stud? And I'll just put a ruler next to it so you can get a rough idea of the dimensions. And the reason I wanted to know that was because obviously if I go ahead and buy my own tool holders, there's some quality suppliers in the UK where I can buy those for reasonable prices, but there's a whole range of pull studs that are available, and some might even have to be custom made, and I didn't want to be stuck because these dimensions, this angle here, 45 degrees, this dimension are critical because the mechanism inside here would expect this to be a certain length so it can pull the tool into the spindle correctly and apply the correct load. Good news is, so two things. One, I've measured all these, and I'll put up on screen now a technical drawing that I made to most accuracy that I could, so just be careful, but I think it is pretty close. So that'll help you. I also managed to find a source of these on eBay, and they're what are called Type A, and I'll put the listing up here. And the good news again, they're not too expensive. So the reason I'm interested in that, yes, they've got to be the critical size, so they definitely work in there, because if you put a longer one or shorter, it's not going to work. And then the other thing is, maybe not so much in the hobby world, but industrially, commercially, these would be considered to be throwaway service items. You know, it's hardened, but eventually that could wear out or have damage and so on. Obviously you don't want that to break and have the tool fly out. As a hobbyist, maybe you wouldn't do that many tool changes, but it's good to have a supply of these because whenever you buy these, they won't have the correct pullstud on, so it's worth. I'll probably get a few of those because they seem quite cheap. Anyway, that's the pullstud, that's the information, and the good news is they seem to be readily available. Okay, let's talk about the bearings. So in between this rotating part and the housing, they've gone for 5 in a row deep groove bearings. Now that's a bit of a corner they've cut there. They'd be reasonably good radially this way, but actually wouldn't be super stiff. Not compared to like a set of angular contact bearings and a guide bearing, which is what you'd see on better quality machines. However, you know, for hobby use, maybe that'll be okay. I guess we'll find out when we try to machine some things, maybe a bit later this year. The other thoughts on that are, especially if you end up making a new housing using this tool, you could upgrade those bearings. You could buy some high quality angular contact bearings here and put a guide bearing at the top in the usual way, or even 2 if you really want to go to town. Yeah, you could upgrade that yourself if, when we use it, that is a limiting factor. But another corner cut, but you know, it's maybe in proportion to the machine performance. Okay, next bit we'll talk about the drive assembly. I'm not going to end up using this bit, but it was only another £8 to have a sort of bracket that goes on here. Obviously they've got a little keyed pulley, 2-speed pulley that would go onto the end of the motor, and I guess you can see that for yourself. That's just going to give you the 2-speed options. There's no edge guide on this, so hopefully they run pretty true. But that's the idea. I think the intent here would be some kind of servo they would want you to put in there, because it's quite small, isn't it? It's not going to be a big 3-phase unit. So maybe a servo driven was the intent. Yeah, actually go that way, wouldn't it? So I'm not planning to use that. I'm going to take that off and do a different arrangement of this. But I thought it was worth the extra few pounds just to see what you got. So obviously I think we mentioned we've got our HTD5 pitch belt there, which would be fine for this application. I think plenty strong enough, and obviously we're driving it like that. Now in the picture these didn't look great quality. I couldn't even tell if they were like just, I don't know, like zinc cast parts, but having them in your hand, hopefully that comes across on camera, that is nicely made. No complaints there. Obviously they've got 2 joined together, got a keyway. I guess they make them on a very long roll, broach them possibly, I don't know, and then chop them to size, but they are nicely made. Yeah, no complaints there. Again, aluminium, they're not steel, but I think for this application that will be fine. And then I think we need to move to the power drawbar bit, because there's quite a lot we need to say about that. There's one last thing on the drive mechanism. So neither of these have a set screw, grub screw, so you know that's not really going to hold them on. So I guess they think you would draw your own for that to suit your own motor, but unfortunately then the same thing applies. If we get that out of the way, oh yes we can, on here. It's just relying on the keyway, and if you can see that, so it floats up and down between the Belleville washers and I guess the top bearing up there. So that's, yeah, that's not ideal. Now the reason that's going to cause me a bit of a problem, I mean generally that kind of okay, I'd prefer to grub screw, but if I hold this end still, I don't know if you can see, there's free play or backlash between those, because you're only driving on this, and they've probably given it a generous clearance to make it easy just to throw together. When I ultimately want to use this, I want to do rigid tapping. Now of course if I need, and my encoder will be off here somewhere, I don't think it was an easy way to get the encoder off the actual spindle. That little bit of backlash is going to cause me a problem, so I've got to think about what I'm going to do about that. The easiest answer would be try and drill a hole here, but I don't think you can easily disassemble it without taking all this off. And yeah, I don't know if I want to go that far, but that's for me to consider for the future. We're here for the review, so let's have a look at what else I'm kind of worried about. Okay, so here's our air cylinder. So this is 80 by 10, so it's 80mm diameter piston, and I think that will be 10mm displacement. Obviously we've got our ports here to pressurise it down or up, and that's important because if we look here, there's a couple of mil air gap there, and that needs to be maintained because obviously this spins when it's milling and this doesn't, so it retracts it out the way, so that's good. However, you probably spotted it already. So this is mounted onto these brackets, onto these tubes, and mounted onto the frame. The upshot is when this presses down and compresses these Belleville washers. Sorry, if you haven't seen those before, they are like very high powered springs, and they've stacked them up either in series or parallel to get just the right amount of preload to hold the tool in. I'll put the spec on the screen. I think it was 300 kilos, so yeah, we'll put the spec on the screen of how much force they're pulling on the tool. It's pretty high. Anyway, to dismount the tool or take it out, they've got to push down on there, compress those washers, and then the tool can drop out, or you can take it out and change it and so on in the usual way. But obviously all the loads are now being reacted by the bearings, those 5 deep groove bearings in here. Now the normal way to do it is to have this floating on some springs, and the bottom of this actually would hook round something. You know, you'd usually have some kind of feature in here, or some kind of I suppose like a fancy washer something you need to get behind, that you can basically just compress the springs and the whole thing is kind of floating. Now, is this a big deal? You know, hobbyist, how many times am I going to change it in a year? Change the tools, that is. You know, how long are these bearings going to last before they get like Brunelling and little grooves in them and start going out of spec? I don't know. However, I was looking at this, and that wouldn't be too bad to convert that. You know, I could see a design there where you could have that floating on springs. The only thing is what to kind of get behind, because you need to have clearance so this can spin, and then whatever comes in here to kind of grab here to squash it down, you need to get up probably onto the back of that pulley. But that would have the effect of squashing those down. But I don't know if this aluminium pulley would take too kindly to that. But you know, that's an option. Or I'll just leave it and see how bad it is. But I just thought I'd point that out. That's another area where they've cut some corners. But yeah, for hobbyists, maybe it's okay. So in summary then, it's probably worth buying your own quality tool holders so that you get a nice consistent length and minimise run out. The pull studs seem to be readily available, so that's good news. In terms of the main spindle itself, yeah, it's aluminium housing, maybe not a deal breaker, but the bearings in here are just deep groove bearings, they're not angular contact, so there's going to be a limitation there. Drive pulleys look really nice, they're just missing a grub screw or two, that's a bit of a shame. And then it's really, you know, great for the price to include the air cylinder, because that additional option can make these very expensive. But they've implemented it in the cheapest and simplest way, which does have some drawbacks that we went through in terms of, you know, maybe Brunelling of the bearings there. But having said that, not bad for the price. Well, you can make your own calls. I'm just giving you the information and you can see what you think. I guess the key thing to do next is clean all the grease off here and have a look at the runout. So it should be no more than 0.05, and if I've got a good one, 0.02. So let's have a look at that. Got it set up, I've got it shimmed at the back so it's level, and I've got a dial test indicator on the bore there, and that is as close as I can get it in the centre. So we've got it zeroed, so let's spin it round and see what we get. Okay, this is a 0.01mm indicator, so each of those gradations is 0.01, so if it's the worst spec, we'd expect it to be there on the 5 tick mark, and if it's nominal, maybe somewhere about 2. So let's turn it round and carefully and see what we got. In fact, right, so that's 0 there, or where we're starting. Oh, that was good. So that's halfway round, it's barely moved. Still under 0.01. Ooh, okay, have I got a good one? And then back to the beginning. Back to 0. Wow. Maybe what they meant was at the end of the tool holder, because that's less than 0.01. That's pretty impressive considering these are low cost bearings. They do say they harden and ground this. I don't know, have I got a good one? Let's try going a bit further in the taper. Let me show you where we're at. Yeah, so we're literally just inside the dogs there, so that was less than 0.01. Pretty happy with that. Let's go a bit further inside and we'll try that again. Right, that's about as far as we can go because the body of the indicator is going to hit that drive dog there, so we're probably gone about another 5-6 mil, so not ideal, but that's all I can do. So here we go, we'll spin it round. Ooh, 0.01. Oh, I've hit something. What's happened? That might give us a bit of a feel. So yeah, we've got about 5-6 mil into the ball. Right, let's try that again. So let's call this 12 o'clock again. Again, less than 0.01, that's halfway round. And yeah, again, pretty good. Okay, so I've got the airline hooked up. I'm only running it about 2 bar, 30 psi, just to put a little bit of pressure on. I'm not quite sure what spec this needed to run at, so we'll have to look that up. And then I've just got this hooked up here, and we'll just touch this onto our 24 volt supply up here. It'll activate the relay. Now there is actually a little shortcut, so you can do it manually down there as well, but I just thought we'll try the electronic way because that's how I'm going to be controlling it ultimately as well. Right, let's hook it up. Okay, that's moved. No. That does not want to go. Actually, I've just taken that off and it's put the pressure on, so it's actually going the other way to what I thought. So it's currently compressed it with no power going to the relay. Yeah, okay. So will that allow me to put the tool in? No. A bit strange because we're almost fully compressed there. Let's put a bit more pressure on the air compressor and see if that will do it. We're at 4 bar, 60 psi. Let's see if that's any better. Let's just cycle it. Okay, that's come off completely. Take the power away. No. I was just letting the air out and just cycling this, and suddenly I think it's grabbing the tool. So what did I do? Oh yeah, right. We'll just try it on the button down here. Oh, it's just out of shot, but there's a manual button. And that has got it. Right, back from coffee break. I've swapped this round, so now A and B go into the other ports. So when we apply power, pressure should go in there to release the tool, and when there's no power, it should just come back. That's how I want it to run. Right, just got the compressor up to full pressure now, so let's see if it works. Here we go. Oh. And let go. Oh yeah. Just realised all the collets I've got are ER32, and this obviously takes an ER20, which I don't have. So I haven't got a way of holding my ground pin in there, but I think what we can do, we can just pick up off this surface here. Is that going to be good? Is that going to be... Yeah, because I mean, it's not going to be quite as good, but I just don't have a collet. So at least we'll get that offset, what that's doing, and hopefully it'll be fairly close to what the end of the tool would be doing once it's in the collet. Alright, so the best we can do is just pick up off the inner part of the tool holder there, which is going to be close to the tool, but you know, not exact. So we've got that at 0, and should allow me to turn it. Oh yeah, okay. So I think it's either, oh yeah, so we're at 12 o'clock, let's say there. Looking good. Oh, there we go, right. 0.03, I'll make that. There's the maximum run out. 0.03 millimeters, or is that just over 1,000? Yeah, I think so. Anyway, that's good news, isn't it? Because if the taper was 0.01, but we got 0.03 here, it does mean if I bought a high quality tool holder, there's a good chance that might be better. So that's a quick overview of everything you get. Some performance measurements that I can take with the kit I've got. So I think you can make your own mind up if you think this is good value or not, based on what you've seen so far. As I say, it's going to be probably 6 months before this goes into use on an actual machine, and we can actually see what it does, you know, real world. What do we actually get for our money in terms of cutting? But that'll have to be a follow-up video. So you might all be wondering, all right, why have I bought this then? I do have a CNC router which can route aluminium, wood, plastic. It can do a little bit of steel, but because it's got high-speed spindle, you tend to be limited to things like 4mm end mills, and I've done like little grooves for keyways in steel, but nothing more than that. You know, you couldn't hog a block out like this out of steel. It just overheat the bits and just burn them up, because you have to run it quite fast. There's no low-end torque. So we've got the CNC router, but you know, that's no good for steel, for big pieces of steel. We do have the CNC plasma machine that I built last year. Again, that, you know, we can cut metal with that. I think it goes up to about 19mm, but you're going to get a bit of a kerf. There's always going to be an accuracy limitation with plasma cutters. You know, it tends to be good for sheet metal, making into, you know, formed parts, this kind of thing. You can cut thicker. I just don't know what kind of tolerance you'll hold, because you're cutting it with a plasma. So I got that option as well. But what I don't have is the ability to not hog out, but do decent work on steel, put flat edges across, you know, billets and things like that, hole patterns, and do a little bit of machining. Now, I don't want a CNC machine. I feel like for the type of work I want to do, I probably just want to walk up to it and twiddle some handles and that kind of thing. So yeah, I'm still working on it, but I've got a plan to build some kind of milling machine, and I thought, let's start with this and see how we get on. So you might be thinking, what kind of milling machine is this going on? We've obviously got the drill press over here with all the upgrades that you might be familiar with. Well, watch out for a future video coming soon. I've done a lot of CAD work, I've been ordering parts. There's a load over there out of shot which you can't see, and oh, go on then, here's a very sneak preview hint of what is to come and where this hopefully is going to end up. Okay, that's everything you get for your money. I think the two big drawbacks are you got the deep groove ball bearings in here, 5 of those instead of angular contacts, and then the power drawbar is fixed, so you apply load onto the bearings every time you release the tool, rather than it being a floating head design. Those are the two corners I think they've cut that are probably going to have most effect on the performance, but who knows, let's see. They're both not insurmountable. You could machine your own block, you could upgrade the bearings, and you could make a floating head on the power drawbar, I think, depending on how well we can get in here to get behind that pulley to provide something to grab onto. I'm not going to use the motor mount, but if you put I think it's designed for a servo motor, that looks like that will drop nicely in there, and it's nicely made. Yeah, so make your own mind up. That's what it costs, that's what it does, there are limitations. Alright, I think all that remains to be said is thank you very much for watching. I'll put links to these down in the description down below, and if you're interested in where this ultimately ends up, it's going to be a big project, it's going to be a long one. Feel free to subscribe and you'll get notification when we get the next steps uploaded. Thank you very much for watching. See you next time.